Welcome to our presentation on the investigation of noise levels produced by various hairdryer brands and different speeds. As we know, household noise can significantly impact our daily lives. Therefore, we aim to assess and compare the noise levels of different hairdryer brands to promote a quieter and more comfortable home environment. As many of us aware, hairdryers generate notable levels of noise, typically falling within the range of 80 to 90 dB. High noise levels emitted by hairdryers can have adverse effects on the auditory system. Increasing acoustical branding by boosting motor frequencies beyond audible range is one unique method for reducing overall noise levels without sacrificing performance quality. We move on to our background project that basically item that we use daily, which is hairdryer. A dryer generates unwelcome loud noise that disrupts communication, reduces comfort, and is potentially hazardous to hearing health. Recognizing the need for improved user experience and minimizing health effects related to noise exposure. Further study and detailed investigation on the auditory performance of hairdryers are crucial. By recognizing the importance of acoustic comfort and addressing the noise issue in hairdryers, we can greatly enhance the user experience and promote overall well-being. Next, the issue that we address in this research is the lack of understanding regarding the possible health dangers linked with the noise levels produced by three different hairdryer speeds. The hairdryer produce significant amounts of noise, frequently ranging from 80 to 90 dB, which falls into the very loud category according to sound level classifications. Long-term exposure to excessive noise levels, such as those created by hairdryers, can result in a variety of health issues, including noise-induced hearing loss and increased risk of stress and anxiety. So, the objective that we want to achieve is we want to investigate the process of capturing and measurement sound signals at three different hairdryer brands. Next, we want to compare the noise produced by different hairdryers brands at three different speeds using Audacity and MATLAB software. And lastly, we want to identify the suitable and best hairdryer brand that can be used for an extended period of time.
Next, the literature review. As Goodwin explains, undesirable noises can have a profound negative effect on our psychological state. It can trigger our brain's instinctual response to monitor sounds for potential danger, even during sleep. Hero also explains noise pollution is a pervasive issue that affects us both mentally and physically. Noise exposure can directly lead to hearing impairment, tinnitus, and distorted hearing. Next, as Dina explains, hairdryers can have detrimental effects on our ears, and it is important to be aware of these risks. Many hairdryers produce sound levels that exceed 85 decibels, which can be harmful to our hearing. You explains the reduction of sound pressure level in hairdryer noise is a complex task, and there are factors to consider. It is challenging due to restrictions imposed by various structural components.
In brainstorming activities, we have made a discussion about type of sound source and variable that need to be considered in this project. Besides that, we may also manage to record three levels of sound, which is low, medium, and high in 5 seconds. Lastly, we divide the task equivalent to each member in this group. There are two software that has been used in this project, which is RCT and MATLAB. In RCT, we need to open RCT software first and connect the microphone. Select habilitated as USB audio as the playback and recording device. Set the recording channel to mono and position the microphone 4 cm away from the air outlet grill. Set the head dryer to a low level and click record in RCT and turn on the head dryer simultaneously. Record the low level head dryer noise for 5 seconds and stop the recording. Save the file as low-speed hairdryer noise in a UP3 format and export the file as AWV. Repeat for medium and high noise level. For MATLAB, we use MATLAB to code and analyze the data and graph by import the file which has been transformed in WAV format. Repeat the step from 5 to 11 to record the noise level in medium speed level and high speed level by changing the level of speed in the hairdryer. Tabulate the data to compare the noise produced by the hairdryer at three different speeds.
Next is the design concept. The analysis of oscillogram of the signal amplitude versus time graph and frequency spectrum magnitude versus frequency graph of the signal using MATLAB software in four different brands of air dryers. Next is the tabulation of data of signal statistics and dynamic range values. The table below shows the maximum value, minimum value, mean value, RMS value, and dynamic range values for four different brands of air dryers. The figure below shows the MATLAB data coding used to obtain amplitude against time graph and magnitude against frequency graph. Lastly, the figure shows the coding used to obtain signal statistics and dynamic range values. These are the coding used to compare the four different brands of air dryers in MATLAB software in three different speed levels to identify the suitable and best hair dryer that can be used for an extended period of time. Next is the discussion part. The analysis was conducted on four different brands of air dryers such as Kind, Kennel & Co, Delia, and Gimmick. The oscillograms and frequency spectrum graphs were examined to determine the highest peak coordinates at each speed levels. Among these brands, Delia constantly exhibited the lowest amplitude and magnitudes, indicating quieter operation. Furthermore, the root mean square RMS values were calculated, showing that Delia had the lowest overall noise intensity. Comparing the dynamics range values, Delia also had the narrowest range of noise variation compared to other brands of hairdryers. In summary, Delia impresses with its exceptional noise reduction, focus on user health and overall performance, making it the most suitable and best hair dryer for prolonged usage compared to other brands of hair dryers.
In closing, by using Audacity and MATLAB software, we can capture and measure sound signals from three distinct hairdryer manufacturers at three different speeds. The purpose was to assess the noise generated by different devices and select the best hairdryer for extended use. Among the brands, Delia consistently had the lowest amplitude, indicating a quieter operation. Furthermore, frequency spectrum graph of magnitude versus frequency demonstrated that Delia consistently had the lowest magnitude, confirming its silent operation. This suggests that Delia makes the least amount of noise. Taking into account all of the listed data, Delia emerged as the most appropriate and best hairdryer brand for long-term use.